Welcome to another session of Circuits and Networks. In today's class also we are going to deal with mesh analysis and node analysis, and this particular session we are going to treat as class 2. So you can see there are two identical networks where we are going to apply loop analysis, where we are going to find out loop currents I1, I2, I3. Then we are going to apply node analysis, where you are going to find out the node voltages V1, V2, V3, and then we are going to estimate the branch currents. The example for branch current is 4 ohms, 2 ohms, 3 ohms. In both the cases, we need to find out the branch currents. So it depends upon the analysis where you're going to obtain the branch currents under mesh as well as node. Just compare the results after getting the loop currents as well as the node voltages and compare the branch currents in both the cases, and then you can get a conclusion that whether you employ mesh analysis or node analysis, the branch current where you are required, that is to be the same. So let us start with the basic example. Here you can see we have to obtain the branch currents using circuit analysis. I have taken this problem as using circuit analysis. In competitive exams, it will be given as the circuit analysis, or they will simply ask you to obtain the branch currents, power or voltage across the elements. So in general exams, they'll be asking the question under mesh analysis or node analysis. If the question is framed under mesh analysis, how to solve this? So for that, I have selected the direction of the loop currents I1, I2, I3, all in clockwise directions. So by proper inspection, I1 is equal to 2 amperes. So this loop is done. So we have framed I1 is equal to 2 amperes, and with this apply KVL to loop 2, because here we don't have the loop currents. So first loop current is given, but the second loop current, third loop current is not given. So applying KVL, that is algebraic sum of the voltage in a closed circuit is equal to 0. So just take the drops. So here you have 4. So it becomes 4 I2 minus I1 plus 2 I2 plus 8 I2 minus I3 equal to 0. So this you can treat as equation 2. Just have substitute the value of I1 in this particular loop. Then I have solve this equation in a proper way. So we are going to get as 14i2 minus 8i3 is equal to 8. So treat this equation as 2. Then apply the same analysis, that is Kirchhoff's voltage law on the third loop. Treating this to be the dominating loop, we are going to obtain 8i3 minus i2 plus 18 is equal to 0. With this, you are going to get the value as minus 8i2 plus 8i3 is equal to minus 18. Now this solve these equations 2 and 3. Then you're going to get the value of I2, which is equal to minus 5 by 3, which is equal to minus 1.667 amperes. Similarly, you're going to obtain the value of I3, which is equal to minus 3.916 amperes. So we have I1, I2, and I3. So with this, we can obtain the branch currents. So first branch current is under 4 ohms. So 4 is shared between loop I1 and I2. So the difference of the current will be I1 minus I2. So substitute the value of I1 and minus of minus the value of I2, which will give you the value of I4, which is equal to 3.667 amperes. Similarly, the branch current which is flowing through 8 ohms will be equivalent to I2 minus I3. I2 we have minus 1.667 minus, already we have the value of I3, which is under minus 3.916 amperes. So just substituting those two values, and thus we obtain the value of I, that is the branch current in 8 ohms, which is equal to 2.49 amperes. Roughly you can take this value as 2.5 amperes. So this is how we solve the basic mesh analysis problem. So if at all we need to solve using node analysis, so identify the nodes V1, V2. Okay. Now you can see V1 and V2. V1 is connected to 3 parameters. So we have 3 branches. V2 is also connected to 3 parameters, but 18 volts is directly connected across 8 ohms. So therefore V2 changes to 18. So just apply the KCL at node 1, that is the algebraic sum of currents at particular node is equal to 0, or at particular node the input current is equal to the output current. So here you can see minus 2 amperes, it is coming towards node 1, and I'm treating node 1 to be at higher potential, and the current which is coming towards it I'm treating as negative, and the current which goes away from it like V1 minus V2 by 2, it is the outgoing current, plus V1 by 4, it is also an outgoing current. So with this you can simplify and get the general equation for node 1 as 3V1 minus 2V2 is equal to 8. So in the previous analysis, we have taken 1 to 3 equations. So for this particular equation, I'm treating as 4. And no need to apply KCL to node 2y. As I told you, V2 is equal to 18. So directly we know the value of V2. So just substitute the value of V2 in equation 4. Then you're going to get the value of V1, which is equal to 14.66 volts. Now after obtaining the values of V1, V2, calculate the branch current. Branch current which is flowing in 4 ohms. So I4 is equal to, according to node analysis, it is V1 by 4. So this you can easily obtain from Ohm's law. So we have V1 which is equal to 14.66 divided by 4, which will give you the value as 3.665 amperes. Now this is the same value of current which we have obtained using mesh analysis. Similarly, obtain the value of current which is flowing in this branch 8 ohms, which is V2 by 8, that is 18 by 8, which is equal to 2.49 amperes or 2.5 amperes. So this is how you inspect the result under mesh analysis and node analysis. Now you can see a 3-loop circuit. Obtain the branch currents using circuit analysis, as I told you. A general way of obtaining the question is nothing but we have to obtain the branch currents irrespective of node analysis or mesh analysis. We need to obtain the branch current. So you can follow mesh analysis. Under mesh analysis, we are treating 3 loop currents as I1, I2, I3. Now, fortunately, here I1, I2, I3, all 3 currents are already given. By proper inspection, you can see I1 direction is clockwise, that is we have selected, and the given direction of current 14 amperes, it is acting opposite to this. So I1 is minus 14 amperes. Similarly, I2 has selected in clockwise, but the given source current is acting opposite to I2. So I2 is equal to minus 8 amperes, whereas I3 it is equal to 10 amperes. So we have obtained just the loop currents. What we need to know? We need to know the branch currents. So one branch current which is flowing through 4 is nothing but, you can see I1 is assigned with the green arrow, whereas I3 is acting opposite to the green arrow. So here I4 is equal to I1 minus I3 under mesh analysis. So these 2 loop currents will give you the value as minus 14 minus 10, which is equal to minus 24 amperes. Now this is one branch current. Similarly, you can obtain branch current which is flowing in 3, which is equal to I1 minus I2. So I1 is clockwise and the arrow direction is also acting according to the selected clockwise direction of current, and the value of I1 is minus 14 minus, here you have I2 as minus 8, so minus of minus 8 will give you the value as minus 6 amperes. Treat this as equation 2, and now apply the analysis for branch current which is flowing in 2 ohms, which is I2 minus I3. Why I2 minus I3? Because this arrow, green arrow, it is aligned with direction of I2, whereas I3 is acting opposite to this green arrow which is flowing in 2 ohms. So minus 8 minus 10 will give you as minus 18 amperes. So this is how we have solved this problem using mesh analysis. One may have a doubt. What if we select the direction of the currents opposite? Or some people, what they do, they'll take the direction of the loop currents according to the source currents given. For example, 14 amperes is flowing in this direction. So I'm going to apply the loop current I1 according to the 14 amperes. So I1 will be equal to 14 amperes. Similarly, I2 it is flowing in this direction. So I2 is equal to 8 amperes and I3 is equal to 10 amperes. So some text you can see this way in which the direction of the loop currents are selected. So if this is true, let us apply the same logic. I4, that is, you can see this brown arrow, it is flowing through 4, which is opposite to I1 direction, opposite to I3 direction. So that's why it is minus of I1 plus I3, which is nothing but equal to minus 24 amperes. The same result we got when we have employed the previous method with all the loop currents in clockwise directions. Is this clear? Now I3. I3 it is going in downward direction. You can see I1 it is acting opposite to the brown arrow, whereas I2 is acting in the same direction of brown arrow. So thus the branch current becomes I2 minus I1, which is 8 minus 14. Again it is giving us the value same current as minus 6 amperes. Now tell me the value of the branch current which is flowing in 2 ohms, that is minus. Why minus? Because I2 is opposite to the brown arrow, I3 is also opposite to the brown arrow, so minus of I2 plus I3 will give you the value as minus 18 amperes. So you have seen that whether we have applied solution 1 under mesh analysis for this problem, we got the same result. And one thing you have observed in the previous case and this case, that is in this direction, 5 ohms, 11 ohms, 1 ohm is neglected. Why they are neglected? Because current in series from this point to this point remains the same. Similarly, current in the series circuit from this point to this point, so 10 amperes in series remains the same. So whether you have 11 ohms or not, the current in series remains the same. Similarly, 14 amperes, the current remains the same, and 8 amperes, which is flowing from this point to this point, will remain the same. That's why the circuit is changed to this, and we have obtained the same result for branch currents. So another way to check whether this approach is right or wrong, that can be done with the help of node analysis. So for node analysis, both the circuits I have taken, I told you whether 5 ohms, 11 ohms or 1 ohm, which are arranged in series with 14 amperes, 10 amperes and 8 amperes respectively. If at all you neglect them, they doesn't change the value of the circuit. So this is the same circuit. So these two circuits I'll apply node voltages V1, V2, V3, V1, V2, V3, and just treating particular node to be acting at higher potential, applying KCL respectively for node 1, node 2, node 3. So for node 1, you can see 14 amperes is going away, 10 amperes is going away. So 14 plus V1 minus V2 by 4 plus 10 equal to 0. With this, you can change the equation to a simplified equation and apply the same logic to node 2, applying KCL to the node 2. So we have V2 minus V1 by 4, that is one branch current, plus V2 minus V3 by 2, this is another branch current, and third branch current is what? V2 minus 12 by 3. So this you can simplify and you can treat this equation as 2 and applying the KCL to node 3. So you have incoming current minus 10, incoming current minus 8, and you have V3 minus V2 by 2. So minus 10 plus V3 minus V2 by 2 minus 8 equal to 0. So what we have done? We have applied KCL to node 1. So we framed equation 1. Simplify this equation and treat this equation as equation 4. So I'm going to get, you can see I have taken LCM as 4. 14, 10 gives 24. 24 you take it on the other side of equation 1, it becomes minus 24. Now you have denominator 4 multiply with minus 24, you're going to get minus 96. So this is how you simplify the equation, and this equation I'm treating as equation 4. So we have already applied KCL at node 2. So take LCM value and you're going to get the equation as minus 6v1 plus 26v2 minus 12v3 is equal to 96. If you divide by 2 or divide by 3, this can be further simplified. And if you keep the same value, doesn't matter. So let us take this equation as equation 5. And with KCL at node 3, we got the equation which is simplified as minus v2 plus v3 equal to 36. Now you have equation 4, 5, 6. So solve equation 4, 5, 6. You're going to get the value of V1 as minus 102 volts, V2 as minus 6 volts, V3 as 30 volts. Now once we obtain the node voltages, estimate the branch currents. So what we are interested to know, we are interested to know the current which is flowing in 4, in 3 and in 2. So in 4 it becomes I4 which is equal to V1 minus V2, V1 minus V2 by 4. So this assumed to be the dominating node. So V1 minus V2 by 4 will give you the value as minus 102 minus of minus 6 by 4 because V2 is minus 6. So this will give you as minus 24 amperes. You can check this answer already we got the same value in the magnitude form when you apply the mesh analysis. Now get the value of branch current which is flowing in 3 ohms, which is equal to V2 minus 12, V2 minus 12 by 3. So substitute the value minus 6 minus 12 by 3, which is equal to minus 6 amperes. So in the two mesh analysis cases, we got the same result. And finally, the current which is flowing in 2 ohms, that is V2 minus V3 by 2, so which is equal to minus 6 minus 30 divided by 2, which is equal to minus 18 amperes. Another quick way to check whether we have done wrong, right or wrong, just go through this node 3 where you have 8 amperes which is coming towards the node V3, 10 amperes which is coming towards the nodes V3, 10 plus 8 becomes 18 and 18 is flowing towards 2 and the given direction of current is acting opposite to that. So plus 18 direction of current is opposite to the resultant, so that is why it is minus 18. So this is how you cross check the quick result when you are going to get a confined answer whether we are doing the right way or wrong way. So this is how you solve complicated problems under mesh analysis and node analysis. I hope this basics will give you a good information about mesh analysis and node analysis. So in today's class we have done with mesh and analysis pertaining to this kind of a problem. Whether you employ mesh analysis or node analysis, we are going to get the same result. So I hope you like my video. Please share among your friends, subscribe to my channel and please press the bell icon for the future notifications. Thank you.